Welcome to our lesson practice for lesson 3 from chapter 1. So 1.03, just to kind of recap and summarize what the lesson was all about. It's very specifically talking about function families, where we can talk about different function families based off of what they look like and their features, including minimums and maximums, increasing, decreasing, positive, negative, and the domains and ranges. So there's definitely ones that you should know or should be familiar with from Algebra 1, like quadratics, absolute value, exponential functions, and linear functions. The new ones that we're going to kind of look into here are square roots, which you see with the red, cubic functions, and sine functions on the far right. So let's get into it. For problem number 1, we are going to be circling the point that is a maximum. So in this one here, when we look at the graph over here in red, we see that the highest point is what we call a maximum, highest meaning the y value here. There's a lot of different maximums that we could kind of choose from here that I'm marking in purple, but the ones that we're limiting to is just A, B, C, and D. So our answer for this one, a maximum would be at A. For number 2, it says a point that is on an increasing interval. So increasing means like from left to right, we are going up. So as we look at that, we should see that B here is at an increasing interval. And then on a negative interval, negative means that the y values are negative, the outputs are negative. So if we're looking at A, B, C, and D, A would be a positive, B and C land on 0, and so the only negative point here would be at letter D. Number 4 and 5 are talking about these two graphs of two different function families. Which families do they belong to? So the top one here, kind of, again, looking back at what we've seen before from Algebra 1, as well as these kind of three newer ones, I can tell that that sine function is the one on the top, whereas the bottom one here is a quadratic. It looks like a upside down parabola. Describe a feature that both of these graphs share. So there's lots of different things that we could talk about. Again, they were listed in the summary, like positive and negative. Wouldn't be a great one because the sine one is always positive. Quadratic looks like it's always negative. The domain, however, something that they share, looks like with these ones here, they're going on forever in both directions. So I would say that they have the same domain, because this one here kind of looks like it's going on forever to the left and to the right, as well as we know a quadratic goes on forever to the left and to the right. So their domain would be the same, which is all real numbers. And there's also, like, if we wanted to be a little bit more specific, we could take a very, specific spot in the graph and mention that, like, hey, at this section right here from, these x values here, we would see that both functions are decreasing, right? So there's lots of different things that we could choose. Another thing is that they both would have a maximum value because sine functions, keep kind of going up and down and hitting the same highest value, whereas quadratics also have a maximum or minimum. For number 6, select all of the function families with graphs that have a maximum or minimum. Okay, great. This is a good segue that I was just talking about for number 5. So sine here, I would say that yes, sine has a maximum or a minimum because it kind of keeps bouncing back and forth from its highest and lowest point. The quadratic definitely has a minimum or a maximum. Parabola, kind of turns around at a certain point. A cubic function does not, because a cubic function goes on forever, both up and down. A square root, I would say, does have a minimum or maximum because, again, if we're looking at a square root function, it kind of looks like that green one I just drew. A better option might be, any of these four. You can kind of see it starts at a certain point and then goes on forever in a certain direction. So it would have a minimum or maximum depending on where it starts. And exponential, so exponential is a little bit tough to talk about because with exponential functions, they go up forever and they also technically go down forever, even though they will have this line that they will never cross. And so since it continually goes down, we technically say that they do not have a maximum or minimum value, even though we know that it's never going to cross a certain value. For number 7, label the maximum or minimum of each square root function. So when we're looking at this one here, we can see that looks like the square root function on the red one here kind of starts, let's do this in blue, starts here. So that would be my minimum at, what is that, -1, -4 would be the coordinates. Whereas for g of x here, we'll do an orange, looks like it has a maximum here at, what is that, 1, 2, -3, +2 would be the coordinates. And so oftentimes when we are labeling, maximum values or minimum values, we could either talk about just whatever the y value is, or we could actually choose the specific coordinate that we are looking at. And so in that one there, it's a maximum. For number 8, select all of the function families whose graphs either always increase or always decrease. So we'll choose pink here for the color sign. Not a good option because it is bouncing back and forth, increasing, decreasing, increasing, decreasing. Quadratic, same idea here, is not a good choice because if we just take a normal parabola here, it is decreasing to start. This first half is decreasing. And then this second half here would be increasing. And so it changes. A cubic function, so if we're talking about these specific ones that we've looked at, cubic functions are always increasing or decreasing. For example, we would see something that looks like this, and although it kind of has this dip in the middle here, technically from left to right is always higher the farther we go to the right. Same thing with the square root function. If we were to take a square root function, looks like this, starts at a specific point and then always increases or always decreases. And also with exponential functions. So again, like we were talking about before, it is always, as we go to the right in this picture right here, it is always getting a larger output or a larger y value. For number 9, for each cubic function shown, determine if the graph is always increasing or always decreasing. And so in this one here for the red function, f of x, we can see that as we go from left to right, our y values are going down, and so we would say that this is decreasing. For our g of x, as we go from left to right, the y values are always increasing, even if it's a small amount. It is never decreasing. So this graph is always increasing for g of x. And for number 10 here, how could you change one function's graph, including its domain, to make it look like a function from another family? Sketch a graph if it helps support your thinking, show, or explain. And so one of the options here, there's a couple different possibilities as far as answers go, but for example, if we took the quadratic function here and we took some sort of parabola, my drawing isn't going to be perfect. Let's zoom in on this a little bit. So I take my parabola here. If I were to kind of change the domain, meaning if I was just to look at, let's say, this right side here, and then if I were to kind of flip that, what we could end up getting here is something that would look like this, which would be kind of like our square root function. And so obviously you can kind of see that it takes some changing to do, right? We have to change the domain, meaning we're like not looking at any of this side right here. We're really just looking at the highlighted piece. And you can kind of see that we are flipping that over this line right here, this beautiful rainbow line. We're like taking that blue arrow and then flipping it over to make that green arrow. So again, there's a couple different possibilities for the answer for number 10 here, but that would just be my choice in how to write that. Lastly, we got our spiral review, the way that we look back on old problems to make sure that we're set up for success in the future. This one here for number 11 asks us to determine the domain and range of the given graph. So for the domain, I'm looking for like what are the possible x values. Looks like it is continuous, not discrete. And so I can see my lowest x value here is -5, and my highest x value looks like it is at +9. So the way I would write that would be all the way from -5 less than or equal to x, which is less than or equal to 9. The range is really just looking at y values. So our lowest y value, again, when we do this, we're going to start here. This is going to be our lowest value, and this is going to be our highest value. So it's no longer reading from left to right because we're not talking about lefts and rights. With range, we're just talking about outputs or y values, which are going up and down. So our lowest y value here looks like it's at -6. And our highest y value up here looks like it's at -1. And so this is the way we would write our domain and range. And again, we want to kind of keep it consistent where our first number is the lowest value so that our formatting is correct. That wraps it up here for lesson 3. Soon we got lesson 4 coming up here, which we will continue to talk about these functions that we are dealing with here.